Hi, Sam Engel, organizer of Calculation League and GMCA. I'm going to share this video with you that was kindly made by Jure, the Herzegovinian Calculation League competitor. He finished 6th place in Season 2, 9th place in Season 1. He was the most improved competitor in Season 2, showing great visualization and some interesting strategies for solving questions. In this video, he demonstrated doing 10 custom format questions from a qualification mode, and then he walked through how he thought about the questions and how he would approach them, if something went wrong, what went wrong, etc. So hopefully this video may be of some help to some people who are considering getting involved in mental calculation or competing in Calculation League. Thank you.
Hello everyone, my name is Jure Colak. I'm a mental math competitor. I was in Season 1 and Season 2. In Season 1 I finished 9th and in Season 2 I finished 6th. And today I will be showing you guys some custom format questions. So what I'm going to do is one simulation for qualification. I will do 10 questions and I will let them all be custom format questions. So this will be some intermediate level for people who know basic stuff like cross multiplication or cross division and stuff like that. But in custom format questions we have a lot of different questions that are like very peculiar, so I will be explaining those more. And why qualification, I will start for some, I would say, intermediate level. So I will see questions that I get wrong. I will tell you how I wanted to do that, but I maybe had too little time or just miscalculated something, and those that I do correct, I will explain to you guys how I solve them. So here we go. Okay, so I did 7 out of 10, and I feel really bad about this one. Like 2018. Oh, okay. So this one I was close, like 83, 82. I'll explain the mistake I did. And this one, I really hate these kind of tasks, like I'm very bad at them, because, I mean, I can memorize numbers at some point, but sometimes I just get lost and then I have to calculate it all again and everything. So I will now explain all of these tasks, how did I do them. So first one is 3 times 563 times 160. Okay, so first thing I did, I wrote 0 so we can forget it, okay. Then I calculated 3 times 16, I know that is 48, and then I did cross multiplication. I imagined like here I had 48 and then I did cross multiplication with these numbers, but what I see can be to some of you maybe easier, I don't know, like different people have different accesses, so I will tell more than one way to do some tasks. So 3 times 563, it is 1689. So maybe some of you find it easier to like memorize bigger number and then multiply it by smaller, because this can also be set like 4 times 4, so you can maybe also do 1689 times 4 and then the result times 4. So this is just normal multiplication, nothing special about that. So let's go to the next one. Sum of 4 or less squares. I'm still not so good in this type of tasks, like I'm practicing them, but the way I do that is, especially when it's just 4-digit number, it's a low number of digits. So I know that 39 squared is 1521. So 1567. When I do 39, then I did make a mistake. I calculated it was 1521, and then I tried to find, you will see that in the footage, I did 622, which adds up to 44, but it's actually difference from this and this number is 46, so that's why I later put 631. But the thing about sum of squares is that you have to know when can you make, like you should use the biggest square under this number, so lower than this number, and it is 39 squared, 1521, because 40 squared is too much, it's 1600. But the thing is, you should know when can you use the rest that you have left, when can you write that as sum of 3 squares, because you have already used one. So let's take, for example, if we have 1528, sorry, and we use 39. Okay, we use 39, and now we have 7 left. From 1521 to 1528, we have 7 left. It is not possible to write 7 as sum of 3 squares, like it's just not possible. And one interesting thing is that no number that when divided by 8 gives 7 as the its modus. His modus is 7. For example, numbers like 7, 15 or 23 and numbers like that, they cannot be written as sum of squares of 3 numbers, because there is logic behind that, like that every number that you square, when you divide his square by 8, you can only get remains 0, 1, 4, and I think that's it, yeah. So when you try to add these numbers to 7, like their notices, you just cannot do it with 3 numbers. So numbers like 7, 15, 23 and stuff like that, you cannot get them as sum of 3 numbers, squares of 3 numbers. So if we had situation 1528, we could not use 39, we'd have to use 38. And then we'd have 84 left, because 38 squared is 1444, and then 84, we can write that, for example, 8, 4, and 2. So on numbers that you have the remain 7, 15, 23, and numbers that have the rest 7 when divided by 8, you cannot write that numbers as sum of 3 squares, so you don't want to get to those numbers at all. So now I will just delete all of this and we'll go to the third task. So the third task was this huge multiplication. So the way I did this, when we have 9, 3, 9, 7, and 98. Okay, so the way I did this, I do 1-digit numbers first, because I find it easier to I don't know how to say this. I find it easier to like multiply these small numbers faster. I can multiply 9 times 9, 81. I can do that rapidly. So 81 times 7, 567. Then that's times 3, 1701. So I can do that rapidly, and when I do that rapidly, I get the result that in this case we have times 98. If this was some other number, I would just like imagine that here it was 1701 and I will multiply it by cross multiplication. I mean, you can also use school method, but I'm very bad at school methods, so I use cross multiplication for all numbers that have more than 2 digits, except in some cases, but rarely. So how did I do this? 1701, we can multiply that by 100, and we can take away this times 2, so we actually have 100 minus 2 is 98, so we can do that. So we actually have something very easy minus something very easy. It just requires memorizing numbers, and 1701 is 3402, and then we have our result. Okay, so that's it about the third task, and now we get to the fourth way. Where did I go wrong in this task? So I have one flaw when I calculate it. I try to do stuff like this, like I don't calculate them at all. I just try to do it like faster, but not with less quality. So I have higher chances of not getting it right. So when we have 693 to 1827. So I saw that this was like this number is 85% of this number. So we have 85%. So what should we do with that? We should take 85% from this number, 98. And then I did a mistake. I thought, oh, okay, so 85% of 98, it should be a little bit more than 85, and it's actually, it should be a little bit less than 85. So that's why I tried numbers 83, 3, 4, 5, 6, 7. So, but you should know that 85% of 98, it should be less than 85, because 85% of 98 is exactly the same as 98% of 85. So this is all just averaging numbers. I'm not calculating anything. I just saw that this was around 85% and I did that. I mean, I didn't solve it, but this is not so difficult. This is like literally 83 or numbers around it, 82 and 84. So this type of tasks, I don't do them like 100% correctly. Like it should be 98 times 693 and then dividing it, but it will require more multiplying and more division, and I just prefer to do it like more quickly but with less accuracy. So you can pick, you can either multiply these numbers on the exact same way as here, like 69300 minus 1386, and then get a number and then divide. But doing all that in the head, I don't think it pays off with numbers small like this. I mean, I knew the number was gonna be 2 digits, so it doesn't require that much of accuracy. So I suggest that here you do averaging, and if it was like, I don't know, if here was 6-digit number, then you should calculate it, because you can't average 5-digit number that would be in the result. Okay, so next task is this one, and these were new and these were very weird when they first got in the competition. So what should you do here? I will just delete all this stuff for a second. So you should search for like number in one equation. In the system of equations, you search for one number that is very much greater than the other number in the equation. So it's 403, it's a lot bigger than 8. So we should get pretty good averaging of 403, or even correctly in this case. So 403, 30 is too big. We try 29, we multiply by 29, 11612, and then we have the rest. Oh no, wait. Okay, so this is 11687, yeah. So we should get here 168, yeah, that's good. So when we do these, we can just focus on 403x plus 8y equals 11855, yeah. So we can divide this by this, and we see we get 29. If we take 28, for example, we will definitely have a lot smaller number, 11284. So when we see what y should be, it should be like a number greater than 500. So we cannot get that with y being just 30, because x and y don't get over 30, if you didn't know that. So it should definitely be 29, and then when you calculate that, 6, 8, 7, when you do this, you will get 168, and you divide it by 8, and it's 21, so result is 29 and 21. Okay. Then sixth one is just, so I won't even draw this one, so it's like just 3 times 2684. I think most people can do that like in just school method. I mean, you can do cross multiplication if you need to, but it's pretty easy. So this one, I don't know how I didn't solve this one. Like, I should have solved it, but when I did, Yeah, okay, my mistake was when I tried, I saw that this number is pretty much larger than this. So when I had 85x plus 9y, so I first tried 4 and it's too large, you get 340. Then when you try x3, you get 255, and then there remains 77. 77 is not divisible by 9. And when I tried 2, when I was doing 332 minus 170, I somehow got 152, and I figured, oh, okay, that is not divisible by 9, and I made that mistake. So it cost me like not just one task, but also 10 to 15 seconds. But yeah, that is bad. So when I saw that none of these numbers was working, I tried to go to 167 plus 77, and then I got lost, and yeah, I didn't solve it. So that is the thing that that most people would solve, but never mind. And the important thing also is if you do some mistake and you see, oh, I could have done that, you can't think about it. You have more tasks to do, so you should just focus on next task and forget about it. Or you can think, oh, maybe some other person that I'm competing against, maybe he also didn't solve some task like that is easy. So you should always give yourself motivation and not bad thoughts, because bad thoughts will lead to you solving next tasks worse. So this one I was very close to not making it, but I did make it. So how do I do these types of tasks? So I will need a second to write all these numbers. Actually, I won't write all of them. I will just write like first few digits. I will not explain it all, because I think you will know what I mean when I do it. The thing is, when you do multiplication and addition of those numbers, like I will just do first 4 digits, for example. 5 times 2099, 71925, and 94189. So I also did this left to right. I mean, I suppose you can do it from right to left. It's maybe easier to some people, but I find it easier to go from left to right, so I don't have to think about numbers that I should add to new addition. I just need to memorize like the numbers I got from previous multiplications. So for example, what do I do here? I do 5 times 2 is 10. Okay, sorry about that. Plus 7 times 1 is 7. Plus 9 times 4 is 36. So I know this is 53. So I memorize 53. And then what I do? Like, the thing is, you can prove that in theory of numbers, but I won't be proving that now. But you can literally write numbers like this, so you don't have to do 5 times 2, it's 0, and we remember 1. I mean, I did like that when I started competing, and I figured out that I have to memorize 3 numbers, and I mean 6 numbers, because when you add these 3, you need to remember all of these 3. So you should, I did it like this. So I memorized, okay, to the next 5 times 0 I need to add 1, to the 7 times 9 I need to add 0, and 9 times 1 I need to add 3. But when you calculate it on the both ways, you figure out that it's all the same. If you will calculate them right away and add them, you will get the same result. So now what do? We remember 53. Then we have 5 times 0, 7 times 9 is 63, 63 plus 9 times 1, 9, so it's 72. So you write like this. I mean, you do this all in your head, but you can see, like, first digit now is 6. Then you have 02. Then 5 times 9, 45. 45 plus 14, 59. And, oh, okay, it's okay. 59 plus 72, 131. So you write 131, and you remember, like, it will definitely be 6-1, maybe 5, but maybe not, so you don't write that right away, and you will get the correct result. So if you do it from right to left, if you want to do it from right to left, you can, but it's literally the same process, but you will write numbers before and remember them after. And I'm just remembering them and then writing them. So it's basically the same thing. You can see, you can try these types of tasks and see what is better for you. And then 9th and 10th, just okay. So 9th, I'm not correct. I didn't get it because these are not so difficult, but I find it very difficult when I have like all these numbers in a line. So if these numbers were just one over or and under one another, it would be pretty much easier to me, but I have to scroll like from left to right, and I don't know, it's just difficult to me. I don't know if you guys will understand, but how do you do that? Like you do 15 times 27. I don't know, I don't have any hints here. Like you just have to multiply, and then you can either multiply all numbers and then remember all of them, and then do addition Jesus, and minus. But you can also do this, then add this, then add this. I'm doing it like that. It's easier to me. So yeah, you can see, but I find it easier to like multiply and add, multiply and add, multiply and add. And about this last one, so I did try two tactics about solving these tasks before. I mean, I did it relatively slow. I should have done it faster, but never mind. So 79 times 249 and square root of that. So you can do square root of 79 and times square root of 249. I did like that before, and I thought it would be easier, but with larger numbers it is far less accurate. So you can get, this is, you don't even have to calculate it, but it's around 8.9. This is around 15.8, and you can just multiply. I don't know, I would do that like 16 times 9 and see like some smaller number, and maybe 140, and yeah, so I mean, you can figure it out like that. But the way I'm doing it is I do cross multiplication, but from left to right. So I think it's very important, like it's very underrated to do cross multiplication from left to right in various tasks, because when you do cross multiplication like that, you can get first 3 digits, and it's actually all that you need. So 7 times 2, 14. Then 7 times 4, 28, plus 18, 46. So you already have that this number is 186 or 7 or something. I mean, you will get now 99. So it will actually be 1959 something. You can see it's 5 digits because when you do multiplication where first 2 digits multiplied get 2 digits, 14 like in this example, the number will have digits as these two combined, 5. But if this was, I don't know, 4 times 2, for example, that number would have had 4 digits. I mean, except if you then get, like, if you get 2 digits on the first place, it's these number of digits, 3 plus 2. And if you get less than 10, if you get 1 digit just, it's 4 digits. So we know that this number will be 1959 or something greater than that. So I just tried 140, like, because I saw first 3 digits, and you can do square root of 5-digit number by seeing first 3 digits. So that's all about this qualification round. I will be doing more of these, I hope so. So if anyone has any questions, you can write them in the comments if you like. I will try to answer them, or if you have some different way to do task, you can also say it. So yeah, that's it for today, and goodbye, good luck.